So hello everyone, greetings from my side. For starting with my introduction, my name is Praveen Kishore Pragya. I am currently in 7th SEM at SDMCET Dharwad. Related to my course, Advanced Computer Architecture assignment, I have done some research or I have followed some observation on the problem statement, which was comparison of the bubble sort or the implementation of the bubble sort on two different architectures, which was one PC or the computer or my laptop, and another one was my mobile phone, and comparing out the performance of the bubble sort on these two architectures, and then reasoning out why there are differences in the observation or the performances. So today we will be seeing these things, like starting with the introduction and then going out with about the bubble sort, then specification of the hardware and the software, and then we will see the code, then we will see the observations what I have seen in the execution time and all, and after that I will be concluding these all things. So first of all, the thing which we are going to see is the implementation of the bubble sort on two different architecture as earlier told, one on the PC and the mobile phone. For the PC part, I will be using a Windows laptop, and for the mobile phone, I will be using a Android phone, and we will be sorting 1 lakh elements, that is 10 raised to 5 elements. First, as on array of structures, and then on a simple array which is allocated dynamically, and we will be seeing out the execution time or the performances in various conditions of these two processors. So first of all, we will be seeing some briefings about the bubble sort, that the algorithm which we are going to use for the sorting. So bubble sort usually is just comparison of the elements, and why it is called a bubble sort, because as a bubble pops out in the water by rising up, it also compares out two elements at a time, and in one go or in one traverse of the array, if we are sorting in a ascending order, the largest element is pushed to the uh, last index of the array, and then it fills out in the reverse manner. By in this manner, it just sorts out the array with the various time complexities that have been mentioned here, with the worst case going from O of n square to the best case of O of n, and sorry, and the best and the space complexity is O of 1, that is constant because no extra space is used, that is in place sorting is being implemented. So now for the architecture part, the specifications I have mentioned for the hardware, like for the PC or for the laptop part, I have used the processor AMD Ryzen 5 5600H, that is a high performance processor, which is the latest gen in the AMD series, and having these properties or the features with L1, L2, L3 cache as mentioned, and this processor supports up to 32 GB of RAM, and other details like it is like a 7 nanometer architecture based, and other details are also mentioned on the screen and in the report. Going on with the mobile phone, the processor which is have been used is Qualcomm Snapdragon 730G, which is a 8-core processor based on 8 nanometer technology uh, by the Snapdragon company. These are the following features of this processor which is used in the phone, and other details are on the screen. Now for the software part, on laptop, I have used code editors and compiler. Uh, I have used code for the code editor. I use Sublime Text, and for the compiler, since I am using C++17 as my base language, I have used a compiler, a GCC compiler version 9.2. For the phone part, I've used a code editor called CXS Droid, which was available on the Play Store. And for the programming part, same thing, same code, C++17 based on that I have used. Now we will be seeing out the code, that is for the first of all we will seeing the simple array which is of size 1 lakh. It has been allocated dynamically by using malloc. So we have allocated the 1 lakh elements by using this syntax, that is malloc. And after that, the sorting is done as per the bubble sort. Two loops have been taken, and this has been sorted. Uh, for the array of structures, I have used struct keyword and then define all those structure. And I have three attributes or three members in the structure, like roll number, name, and marks. And after that, I have created the array globally, that is outside of the main, with a size of 10 to 5, that is 1 lakh. And then after that, I have sorted it using the same function, that is the bubble sort, with two loops with a complexity of O of n square. And I have sorted it based on the marks. Okay. Now, what I have observed for the first code, that is for the simple array, I have observed based on two conditions, like while the devices were being charged and while they were on battery mode, or that is were discharging. So for the laptop part, for the simple array, it took 7.22 seconds to execute just that bubble sort part. That is the our main goal, what we have to know. And for the discharging part, when it was on battery, it took almost 10.58 seconds. That is more than when it was on charging. But the conditions were reverse on the phone. While it was charging, it took 22.24 seconds, but while on battery, it just took 17.35 seconds. The reason we will be seeing out later. For the array of structures, the laptop on charging took 23.304 seconds, while when it was on battery mode, it took 31.316 seconds. But again, the change was observed in mobile phone, the reverse thing, like it took 84.44 seconds to just sort this 1 lakh elements of array of structures while on charging. But while it was on battery mode, it took only 65.853 seconds to sort it. So now we'll be seeing out the reasons why this difference has been seen. So first of all, we'll be dealing out how the Ryzen 5, that is the processor used on this laptop, executes the code faster than the Qualcomm Snapdragon 730G, which is used in the mobile phone. Um, what is the difference? Like, first of all, this Ryzen 5 is a laptop-based processor or a desktop-based processor having 6 cores and 12 threads. And whereas on the other side, the Qualcomm Snapdragon is a mobile processor which has although more cores, like 8 cores, but lesser threads, that is 8 threads. But the differences are in the clock speeds and all. Like the base frequency of the Ryzen 5 is 3.3 gigahertz, while on the 730G Snapdragon it is 2.2 uh, gigahertz is the maximum which we can go, while on the Ryzen 5 it can go up to 4.4 gigahertz. As you can see, it is just double of that. So we'll be seeing out only the minimum things, like for the comparison part, on the normal basis, we use the normal clock speed. That's why. Now we will be seeing some comparisons that are based on the synthetic simulators or the benchmark softwares. Like one famous thing is Geekbench for the multi-core and the single core performances of these two processors, that is AMD Ryzen 5 and Qualcomm 730G. I have used the data based on the website gadgetversus.com. As we can see in the single core, the difference is 210%, leading by the Ryzen 5. And on the multi-core, the difference is just double, almost double, that is 412%. As we know, the simple these type of codes that we have used are just CPU bounded. They doesn't need any GPU performances, and it can be executed on a single core processors. That is, they will be using only one core of the CPU. So that's why, since the difference, as you can see, the 200% is there. So easily we can see that the AMD Ryzen 5 5600H is going to execute much way more faster than the Qualcomm Snapdragon 730G for these type of codes. And even if it was a multi-core or some parallel threading was implemented, then also on the multi-core, since AMD Ryzen 5 performs much better, it will be executing the code way faster. Uh, but the thing which we have seen in the execution time, to reason out those things, why Ryzen 5 is working or executing faster when it is charging, the laptop is charging, than the discharging condition, while the opposite was true for the Snapdragon 730G, that is the mobile processor. Like when it was charging, it was executing slower, and when it was on battery, it was executing faster. That is just opposite of the laptop conditions. So we can reason out like a processor's performance, like what are the basic features of a processor? What we see, like we see the RAM capacity, the memory capacity, the clock speed, the base, and the maximum clock speed, the cache details, L1, L2, L3 cache levels, the bus width, the pipelining implementations. We all see these things in the processor to reason out how the performance is going to be. But the thing is, after all these things, if we just see the basic, how what is the major dependency, we can see like the power source that we are using is the main thing. Like whether we are using the main cord power supply, which is basically of 220 volts, or we are using the battery of the devices, or and also the temperature conditions in which we are operating. These two things mainly affects the performances of a system, because the system, uh, as humans, need to work in comfortable zone. They need lower temperature, they want lower temperature to work upon and to work at their best. And also like there are some conditions when if their temperature goes way much higher, the processors or the inner components can burn out. So since so to reduce these temperature, the processors tend to reduce their performances and lowers the temperature. The thing is, in the laptops we have much way modern uh, cooling fans, bigger fans, to reduce or lower the temperature to exhaust out these uh, hot airs. But while in the phone, due to the design issues or the compactness, we can't apply those fans and all for the cooling conditions. So for the laptop, even when the temperature goes higher, the system tends to remain on a cooler side. Like the internal components can work out because the fan is constantly working in those conditions. So we can work out in those things. But on the phone, if the temperature goes beyond the threshold value, the processor reduces its performance uh, at a very low level, so that the temperature can drop quickly, and it can just retain its normal conditions or the optimal conditions. That's why if I say like when it is charging, all the components of the laptop are getting the power supply at their enough conditions or their best condition, so they can operate at their best possible strength. But on the mobile phone, if we are charging and then also using some applications, it is just making it hotter and hotter. That's why it can't work out on its best thing. But when it is cooling, the when both are on the laptop and the mobile phone, when both are on the battery conditions, the battery on the laptop, the battery can't provide that much of power source to all the components like when it was on charging condition. So the performances reduces on those things. But on mobile phone, even if it is working on battery, since it is a single chip on which the CPU and the GPUs are there, so it doesn't have to distribute to everywhere, like on a bigger surface area, like that of the CPU of a desktop. So we can work out like on the mobile phone, the battery can provide enough power source for the working, and since the temperature is also lower when it is on battery condition, the mobile phones work out much better when they are not charging. But the reverse is true for the laptops. So that's why if we want a high demand, if you want to run an application which is high resource demanding on a laptop, we can plug in and work out those things. But the same thing is not true. We if we are on battery conditions on a mobile phone, we can work out with a much better results uh, as compared to the laptop or as compared to the charging conditions of the mobile phone. So that's all. Some supporting links on these reasons have been listed out also. So that's all from my side. I guess I was able to produce something which is useful. Thanks a lot. Thank you.